Section 12-6 is surface areas and volumes of spheres. The definition of a sphere is the set of all points in space equidistant from a given point. If you'll remember, the definition of a circle is the set of all points in a plane, that is two-dimensional space, that is equidistant from a given point, which is the center. A sphere, since it's a three-dimensional shape, it refers to the set of all points in space that are the same distance from a given point, and that given point is the center. A sphere has a center, multiple radii, in fact an infinite number of radii, chords, diameters, and tangents. When a plane intersects a sphere, so picture like a plane going directly through the center of a sphere, and it contains the center, it creates a great circle. In other words, you can have an infinite number of planes that are intersecting a sphere, and they're going to create different sized circles. But when the plane goes through the sphere and contains the center of the sphere, that's the largest circle that you can get, and that's called the great circle. The great circle separates the sphere into two hemispheres, or exactly half spheres. The formula for the surface area of a sphere is S equals 4 pi times the radius squared. The formula for the volume of a sphere is 4/3 pi r cubed. Notice the area formula has the radius squared, so your answers will be in square units. The volume formula has r cubed, so your answers will be in cubic units. Let's try a couple examples. Find the surface area and volume of a sphere with a radius of 4 inches. So my radius is 4, and I'm going to write out the formulas. S equals 4 pi r squared, and V equals 4/3 pi r squared cubed, pi r cubed. Okay, so very straightforward, just plug in 4 for the radius. So S equals 4 times pi times 4 squared, which is approximately equal to 201.1 square inches. For volume, 4/3 times pi times 4 cubed. Punch that into your calculator, and here's a little bit of a suggestion. I would do 4 to the 3rd power, whatever the radius is, hit enter, and then do times pi times 4 divided by 3. And this ends up being approximately 268.1 cubic inches. Next example. Find the surface area and volume of a hemisphere with a diameter of 6 inches. So if the diameter is 6 inches, then the radius is going to be 3. Now this is a hemisphere, and we didn't do a separate formula for a hemisphere. But let's think for a minute about the volume and the surface area of a half of a sphere. The surface area of a hemisphere is a little more complicated. So picture the bowl part, the bottom part of the sphere. That's going to be actually half of the surface area, half of the total surface area, plus you have to include the surface area of the great circle. So to get the surface area of a hemisphere, it's going to be 1/2 of the surface area of the sphere, 1/2 the surface area of the sphere, plus the area of the great circle. So picture a sphere being cut in half. To get its surface area, you're just going to use the bottom bowl part, but then you also have to take into account the great circle that's on top. So 1/2 the surface area of a sphere plus the area of the great circle. Now actually, if you were to simplify this, just multiply by 1/2, 2 pi r squared plus pi r squared is actually 3 pi r squared. So the surface area of a hemisphere is going to be 3 pi r squared, which is going to be 3 times pi times 3 squared, or the surface area is approximately 84.8 square inches. So remember, the surface area of a hemisphere is the surface area of the half of the sphere, the bottom bowl part, plus the surface area or the area of the great circle. Volume is a lot easier. Basically, if you cut a sphere in half, its volume is exactly half. So it's going to be 1/2 4/3 pi r cubed. Or actually, if you want to simplify that, that will simplify to 2/3 pi r cubed. 1/2 times 4/3 is 2/3. Or the volume is equal to 2/3 times pi times, whoops, not 4, 3 cubed, where the volume is approximately equal to 56.5 cubic inches. Find the volume of a sphere find the volume of a hemisphere whose great circle has a circumference of 24 pi inches. So the circumference is pi times the diameter, and they told us that the circumference of this circle is 24 pi. So canceling out the pi's, the diameter of the great circle is 24, which means the radius of the great circle, or the radius of the sphere, is going to be 12. And we're asked to find the volume. The volume is 4/3 pi r cubed, or 4/3 times pi times 12 cubed, where the volume is approximately equal to, oh, wait a minute, that's wrong. My mistake. It was a hemisphere. Let me go back. Sorry about that. We were finding a hemisphere, so I really needed half of that, 2/3 pi r cubed, or 2/3 pi times 12 cubed. There we go. Or the volume is approximately 33,619.1 cubic inches. That's a really good example of going back and reading the problem. I was just thinking sphere instead of hemisphere. Hemisphere is half of the volume of a sphere. Okay, and find the volume of a sphere whose great circle has an area of 55 pi square inches. So the area of the great circle, area is pi r squared. The area of this great circle is 55 pi inches squared, which is pi r squared. Canceling or dividing both sides by pi, r squared is 55, or r is equal to the square root of 55. Volume of a sphere, 4/3 pi r cubed. Yes, this is a sphere, not a hemisphere. 4/3 times pi times the square root of 55 cubed. When you put that into your calculator, I would do the square root of 55. If your calculator opens parentheses when you do the square root, make sure you close it and then cube it. Enter, times pi times 4 divided by 3. And that should give you that the volume is approximately 1,708.6 cubic inches.